Imagine a future where energy is limitless. Picture a world where the constraints of traditional energy sources are a thing of the past, and our planet thrives on an endless supply of clean, renewable power. Where the sun, shining tirelessly in space, fuels our world 24 hours a day. No longer are we bound by the limitations of night and day, or the unpredictability of weather patterns. Instead, we harness the sun's energy continuously, ensuring a steady and reliable power supply. This is the promise of space-based solar power, a revolutionary technology poised to reshape our relationship with energy. This isn't science fiction, it's a tangible, achievable goal that could transform our energy landscape. Imagine solar panels orbiting the Earth, capturing the sun's energy without any atmospheric interference, and beaming it down to the surface where it's needed most. It's a vision that scientists and engineers are working tirelessly to make a reality. In laboratories and research centers around the globe, brilliant minds are developing the technologies and systems required to make space-based solar power a viable solution. From advanced photovoltaic cells to innovative transmission methods, every aspect is being meticulously designed and tested. The potential benefits are staggering, offering a path to a cleaner, more sustainable future for all humankind. Imagine a world where our energy needs are met without depleting natural resources or harming the environment. A world where energy poverty is eradicated, and every corner of the globe has access to affordable, reliable power. This is the dawn of a new era in energy, one that promises to revolutionize the way we live, work, and interact with our planet. The journey is just beginning, and the possibilities are as vast as the universe itself. Our current reliance on fossil fuels is unsustainable. It pollutes our planet, disrupts our climate, and jeopardizes the health of future generations. Solar energy offers a clean alternative, but Earth-based solar panels have limitations. Clouds, nighttime, and atmospheric interference all reduce their efficiency. We need a bolder solution, one that can harness the sun's energy at its source, high above the Earth's atmosphere. Space-based solar power, or SBSP, proposes a simple yet elegant solution. Capture the sun's energy in space where it's constant and powerful, and beam it down to Earth. Here's how it works. Imagine a network of satellites orbiting our planet, each equipped with expansive solar panels designed to capture the sun's rays. These satellites are strategically placed in geostationary orbit, ensuring they are constantly bathed in sunlight, free from the interruptions of night and weather that we experience on Earth. The solar panels on these satellites are highly efficient, converting sunlight into electricity with minimal loss. This electricity is then stored in onboard batteries, or directly converted into another form of energy. The next step in the process involves converting this electrical energy into microwaves or lasers. This conversion is crucial because it allows the energy to be transmitted over vast distances without significant loss. The energy beam is then precisely directed towards receiving stations on Earth. These receiving stations are equipped with large antenna arrays designed to capture the incoming energy beam with high efficiency. Once the energy beam reaches the receiving station, it is converted back into electricity. This electricity is then fed into the local power grid, providing a clean and constant source of energy. The potential of SBSP is immense, offering a way to harness the sun's power without the limitations of terrestrial solar farms. By placing solar panels in space, we can tap into an almost limitless supply of energy, reducing our reliance on fossil fuels and helping to combat climate change. The technology is still in its early stages, but with continued research and investment, SBSP could become a cornerstone of our future energy infrastructure. Imagine a world where our energy needs are met by the sun, captured in space and beamed down to Earth, providing clean, renewable power for generations to come. The advantages of SBSP over traditional solar panels are clear. In space, the sun's energy is available 24/7, unobstructed by clouds, atmosphere, or nighttime. This means SBSP can provide a constant, reliable source of clean energy, unlike the intermittent nature of Earth-based solar and wind power. Furthermore, SBSP can be deployed anywhere in the world, regardless of geographic limitations or weather patterns. Section 5. Turning dreams into reality. The concept of space-based solar power, or SBSP, has been around for decades, but recent technological advancements have brought it closer to reality. Advances in lightweight solar panels, wireless power transmission, and space-based construction are making SBSP increasingly feasible. Several countries and private companies are investing heavily in SBSP research and development. Pilot projects are underway, testing different aspects of the technology. Section 6, A World Transformed. In this chapter we delve into the transformative potential of space-based solar power, or SBSP, and how it could revolutionize our world in ways we can only begin to imagine. The successful implementation of SBSP could have a profound impact on our world. By harnessing the sun's energy directly from space, we can tap into a virtually limitless source of clean power. This technology involves capturing solar energy using satellites equipped with solar panels and then transmitting that energy back to Earth. Imagine a world powered by clean, limitless energy from space. This isn't just a futuristic dream, it's a tangible possibility. With SBSP, we could generate enough energy to power entire cities, industries, and even countries, all while reducing our carbon footprint. Greenhouse gas emissions plummet, mitigating climate change and improving global health. The reduction in emissions would lead to cleaner air, healthier ecosystems, and a significant decrease in the adverse effects of climate change. This shift to clean energy would also mean fewer health issues related to pollution, such as respiratory problems and heart disease. Our dependence on fossil fuels dwindles, leading to greater energy independence and security. With SBSP, we wouldn't need to rely on finite resources like coal, oil, or natural gas. This would not only reduce geopolitical tensions over energy resources, but also make energy more accessible and affordable for everyone. The economic benefits are equally significant. The development and maintenance of SBSP systems would create a plethora of new jobs and industries. From the construction of space-based solar arrays to the development of advanced transmission technologies, the economic ripple effect would be substantial. New industries and jobs emerge in the fields of space exploration, renewable energy, and infrastructure development. Engineers, scientists, and technicians would be at the forefront of this new era, driving innovation and progress. The space industry would see a boom, with increased investments and advancements in technology, further pushing the boundaries of what we can achieve. Moreover, the global collaboration required for SBSP projects would foster international cooperation and unity. Countries would need to work together, sharing knowledge and resources to make this vision a reality. This spirit of collaboration could extend beyond energy, paving the way for joint efforts in other critical areas such as space exploration, environmental conservation, and scientific research. Educational institutions would also play a crucial role, offering new programs and courses focused on renewable energy and space technology. This would inspire the next generation of scientists, engineers, and innovators, ensuring a steady stream of talent to drive the industry forward. Communities around the world would benefit from the widespread adoption of SBSP. Local projects could harness this technology to provide clean energy for schools, hospitals, and public services, improving the quality of life for countless individuals. In essence, SBSP has the potential to transform our world in profound ways, from environmental and economic benefits to fostering global cooperation and inspiring future generations. The possibilities are endless. As we stand on the brink of this new era, the vision of a world powered by clean, limitless energy from space is not just a dream, but a future within our grasp. Section 7. The challenges ahead. Despite its promise, SBSP faces significant challenges. The cost of launching and assembling massive structures in space remains a major hurdle. Transmitting energy wirelessly over long distances with minimal loss requires further technological breakthroughs. Public concerns about potential environmental impacts, such as microwave radiation exposure, also need to be addressed. Section 8. The future of energy. Despite these challenges, the pursuit of SBSP is a worthy endeavor. The potential rewards, both for our planet and our species, are simply too great to ignore. As we continue to innovate and push the boundaries of technology, SBSP could become a cornerstone of our global energy strategy in the coming decades. Section 9. A brighter tomorrow. The quest for clean, sustainable energy is one of the defining challenges of our time. SBSP offers a bold and ambitious solution, a testament to human ingenuity and our unwavering pursuit of a brighter future. While the path ahead is fraught with challenges, the potential rewards are immeasurable. It's time to invest in this transformative technology, for the sake of our planet and Imagine a future powered by the sun, 24/7. A world where the energy we need is harvested directly from the cosmos, ensuring a constant and sustainable supply. This is the promise of space-based solar power. By placing solar panels in orbit, we can capture sunlight without the interruptions caused by weather or the day-night cycle on Earth. Instead of relying solely on Earth-based solar panels, which are limited by geography and weather conditions, we could capture the sun's energy directly from space. This method allows for a more efficient and consistent energy collection. This energy could then be beamed down to Earth using microwave or laser technology, providing clean and reliable power to our homes, industries, and cities. Imagine a world where energy is transmitted seamlessly from space to Earth, reducing the need for traditional power plants. Space-based solar power is still a developing technology, but it has enormous potential. Researchers and scientists are working tirelessly to overcome the technical challenges and make this vision a reality. The advancements in this field could revolutionize how we think about energy production and consumption. It could help us combat climate change by significantly reducing our reliance on fossil fuels, which are major contributors to greenhouse gas emissions. Additionally, space-based solar power could provide a solution to the growing energy demands of our ever-expanding global population. It is a future worth exploring. The journey towards a sun-powered future is not just about technology, it's about creating a sustainable and prosperous world for future generations. By investing in space-based solar power, we are taking a crucial step towards a cleaner, greener, and more resilient planet. Solar panels, whether on Earth or in space, rely on the same basic principle, the photovoltaic effect. Special materials in solar cells absorb sunlight. This light knocks electrons loose from the atoms in the material. These freed electrons create an electrical current. That's electricity. In space, solar panels are even more efficient. They receive sunlight unfiltered by the Earth's atmosphere. This means they can capture more energy, making them a potentially powerful source of electricity. Constructing and maintaining solar arrays in space presents unique challenges. The harsh conditions of space, including extreme temperatures, radiation, and space debris, pose constant threats. Engineers must design robust and resilient systems that can withstand these hazards for extended periods. Transportation is another obstacle. Launching heavy materials into orbit is expensive. Scientists and engineers are exploring innovative solutions like lightweight materials and in-space manufacturing to address these logistical hurdles. While Earth-based solar energy has made significant strides, it comes with limitations. Weather patterns, atmospheric interference, and the day-night cycle all affect energy output. Space-based solar arrays bypass these limitations, capturing sunlight continuously. This constant access to sunlight translates into a higher energy output compared to Earth-based counterparts. Space-based solar power offers the potential for a reliable and consistent energy supply, regardless of weather or time of day. Section 5. Beaming energy from space. Once captured, the solar energy needs to be sent back to Earth. This involves converting the electricity into microwaves or lasers and transmitting it via a focused beam. On Earth, receiving stations would capture this energy and convert it back into usable electricity. This process requires highly precise aiming and tracking systems to ensure the energy beam hits its target accurately. Safety protocols are crucial to prevent the high-energy beam from straying off course. Space-based solar power has the potential to revolutionize our world. It could provide clean energy to remote areas, disaster-stricken regions, and developing nations. This technology could reduce energy poverty and foster economic growth worldwide. Beyond our planet, space-based solar power could energize future space missions, and even support the establishment of permanent human settlements on the Moon or Mars. The energy possibilities are truly astronomical. Developing space-based solar power is a monumental task, requiring global cooperation. International partnerships are essential for sharing resources, expertise, and funding. By working together, we can overcome technical challenges and make this groundbreaking technology a reality. Collaboration extends beyond nations. Private companies, research institutions, and space agencies all have a role to play in advancing this game-changing technology. As our planet faces the urgent threat of climate change, the signs are all around us. From the melting glaciers to the rising sea levels, the impact is undeniable and growing more severe each day. The need for clean and sustainable energy sources has never been greater. Traditional energy sources such as coal and oil are not only finite but also contribute significantly to the greenhouse gases that drive climate change. Space-based solar power offers a compelling solution to this pressing issue. By harnessing the sun's energy from space, we can capture a continuous and abundant source of power. This method provides a continuous and abundant source of energy without emitting harmful greenhouse gases. Unlike ground-based solar panels, space-based solar power stations can collect energy 24/7, unaffected by weather or the day-night cycle. By embracing space-based solar power, we are not just adopting a new technology, we are pioneering a revolutionary approach to energy production. Engineers and scientists are working tirelessly to make this vision a reality, developing advanced technologies and innovative solutions. We can reduce our dependence on fossil fuels, which have been the backbone of our energy infrastructure for over a century. This transition is not just about replacing one energy source with another, it's about transforming our entire approach to energy consumption and production, and transition to a cleaner, more sustainable energy future. Imagine cities powered entirely by renewable energy, where advanced solar panels and wind turbines work in harmony to provide clean power to homes and businesses. This shift towards renewable energy is crucial for mitigating the effects of climate change. Renewable energy projects and clean energy initiatives are being implemented worldwide, showcasing the potential for a sustainable future and preserving our planet for generations to come. By investing in these technologies today, we are ensuring a healthier, more sustainable world for our children and grandchildren. The choices we make now will determine the future of our planet, and it's up to us to make the right ones. Space-based solar power is a bold and ambitious endeavor. It is a concept that has captured the imagination of scientists, engineers, and visionaries alike. Imagine a world where the vast, untapped energy of the sun is harnessed directly from space, providing an almost limitless source of clean energy. This endeavor represents a significant leap forward in our quest for clean energy and embodies the spirit of human ingenuity. The technology required to make space-based solar power a reality is complex and cutting-edge, involving advancements in solar panel efficiency, wireless power transmission, and space logistics. By harnessing the power of the sun from space, we can unlock a brighter and more sustainable future for all. The sun's energy is abundant and constant, unlike terrestrial solar power, which is limited by weather and the day-night cycle. Space-based solar power could provide a continuous, reliable source of energy, reducing our dependence on fossil fuels and mitigating the impacts of climate change. As we look to the stars, let us dare to dream big and work together to turn this transformative vision into a reality. The journey to achieving space-based solar power will require international collaboration, significant investment, and a commitment to overcoming technical challenges. But the potential rewards are immense, offering a sustainable energy solution that could power our world for generations to come. The future of energy may very well lie beyond the bounds of our planet, waiting to be harnessed for the betterment of humanity. As we continue to explore and innovate, let us keep our eyes on the stars and our hearts committed to creating a cleaner, brighter future for all. The dream of space-based solar power is not just a technological challenge, but a testament to our collective ambition and the enduring human. Our planet thrives on the sun's energy. The sun, a colossal ball of fire, is the heart of our solar system, providing the essential energy that sustains life on Earth. Its rays travel millions of miles to reach us, bringing warmth and light to our world. Every leaf, every wave, every breath speaks of our star's power. The sun's energy is the driving force behind photosynthesis, the process that allows plants to grow and produce oxygen. It powers the water cycle, causing oceans to evaporate and form clouds that bring rain. It even influences our weather patterns and climate. We have learned to harness this power, but our methods are limited. Clouds obscure the sun. Night demands a pause. Traditional solar panels, while effective, are dependent on clear skies and daylight. When the sun sets or clouds gather, our ability to generate solar power diminishes significantly. What if we could access this energy directly, constantly, without interruption? Imagine a scenario where the sun's energy is available to us 24/7, regardless of weather conditions or the time of day. This would revolutionize the way we think about and use solar power. Imagine a future where sunlight, unfiltered and pure, fuels our world. A future where the energy we need is always within reach, providing a consistent and reliable source of power for all our needs. This is the promise of space-based solar power. By placing solar panels in space, we can capture the sun's energy without any atmospheric interference, ensuring a constant supply of power. Satellites miles above Earth could capture the sun's energy day and night. These satellites would be positioned in geostationary orbit, where they can continuously face the sun and collect its energy without interruption. This energy, converted into microwaves, could then be beamed safely to Earth. No fossil fuels, no greenhouse gases. The microwaves would be received by ground-based stations and converted back into electricity, providing a clean and sustainable energy source. Just clean, sustainable power from the cosmos. This technology has the potential to drastically reduce our reliance on fossil fuels and significantly cut down on greenhouse gas emissions, helping to combat climate change. This is not a distant fantasy. The concept of space-based solar power has been around for decades, and recent advancements in technology are bringing it closer to reality. It is a field brimming with research, investment, and potential. Scientists and engineers around the world are working tirelessly to overcome the technical challenges and make space-based solar power a viable option. The obstacles are real, but the rewards are too great to ignore. From the high cost of launching satellites to the technical difficulties of transmitting energy over long distances, there are many hurdles to overcome. But with perseverance and innovation, these challenges can be met. Join me as we explore the exciting possibilities of space-based solar power, a future where the sun never sets on human ingenuity. Together, we can unlock the full potential of solar energy and create a brighter, more sustainable future for all. The sun is a colossal fusion reactor dwarfing our planet in size and energy output. Every second it releases more energy than humanity has consumed in its entire history. This energy radiating outwards bathes our planet in light and warmth. Currently, we capture a minuscule fraction of this energy. Solar panels, constrained by geography and weather, can only do so much. Space-based solar power offers a solution, harnessing sunlight where it is most abundant, in space. Imagine solar panels, vast in scale, orbiting Earth. Unobstructed by the atmosphere, these panels would receive sunlight constantly, regardless of time or weather. This constant energy capture could revolutionize our energy landscape, providing clean, sustainable power on an unprecedented scale. The Earth's atmosphere, while essential for life, is a fickle filter for solar energy. It absorbs and scatters sunlight, reducing its intensity and limiting the efficiency of ground-based solar panels. Space-based solar power bypasses these limitations entirely. Positioned above the atmosphere, orbiting solar panels would receive sunlight at its full intensity. This uninterrupted access to solar energy is a game-changer, enabling continuous power generation. Furthermore, space-based solar power eliminates the intermittency issues plaguing terrestrial solar energy. Unlike ground-based panels, which depend on daylight hours and clear skies, orbital panels would continuously bathe in sunlight, ensuring a steady, reliable energy supply. The concept of space-based solar power is not new. It has captivated visionaries and scientists for decades, inspiring countless science fiction tales and sparking serious scientific inquiry. Early pioneers like the brilliant Nikola Tesla envisioned wireless energy transfer, dreaming of a world powered by the heavens. While Tesla's vision was ahead of its time, the fundamental principles he explored are now driving the development of space-based solar power. Today, research institutions and private companies are working tirelessly to turn this vision into reality. Sophisticated designs for orbital solar arrays, energy conversion systems, and microwave transmission technology are taking shape, bringing us closer to a future powered by the stars. Section 5. The Challenges of Construction, a Symphony of Engineering. Building and deploying a space-based solar power system presents a monumental engineering challenge. The sheer scale of the project is daunting, requiring the assembly of massive structures in the harsh environment of space. Transporting materials into orbit is a significant hurdle. Current rocket technology is expensive and limited in its payload capacity. New, more efficient launch systems are crucial for making space-based solar power economically viable. Once in orbit, the construction itself is a delicate dance of robotics and automation. Assembling vast arrays of solar panels, kilometers in diameter, requires advanced robotics and autonomous systems capable of operating with precision in the vacuum of space. Section 6. Beaming power, a delicate dance of microwaves. Capturing the sun's energy is only half the battle. Equally important is transmitting that energy safely and efficiently back to Earth. This is where microwave technology comes into play. Space-based solar power systems would convert sunlight into microwaves, a form of electromagnetic radiation that can travel through the atmosphere with minimal loss. These microwaves would then be beamed to Earth, where ground-based receiving stations would convert them back into usable electricity. Safety is paramount in this process. The microwave beams would be designed to be non-ionizing and to disperse their energy over a wide area, ensuring the safety of humans, wildlife, and aircraft. Rigorous testing and safety protocols would be essential for the responsible deployment of this technology. Section 7. The environmental equation, a balancing act. While space-based solar power offers a clean and sustainable energy source, it is not without its environmental considerations. The construction and launch of space-based infrastructure have an environmental footprint that must be addressed. The production of solar panels, rockets, and other components requires energy and resources, potentially generating pollution and greenhouse gas emissions. However, these impacts must be weighed against the long-term environmental benefits of transitioning away from fossil fuels. Life cycle analyses, which assess the environmental impact of a technology from cradle to grave, suggest that space-based solar power could have a significantly lower environmental footprint than fossil fuels over its operational lifespan. Section 8. The Future of Energy, a Tapestry of Innovation. In this chapter, we delve into the groundbreaking advancements that are shaping the future of energy. From the vast expanse of space to the intricate networks on Earth, innovation is weaving a complex and promising tapestry. Space-based solar power is not a silver bullet solution to our energy challenges. It represents a significant leap forward, harnessing the sun's energy from space, where it is abundant and uninterrupted by weather or the day-night cycle. It is, however, a crucial piece of the puzzle, a testament to human ingenuity and our relentless pursuit of a sustainable future. Engineers and scientists are tirelessly working to perfect this technology, ensuring it can be integrated seamlessly with other renewable sources. The path to a clean energy future will likely involve a tapestry of innovative technologies, each contributing its strengths to the global energy mix. Wind, solar, geothermal, and now space-based solar power all play vital roles in this intricate energy ecosystem. Space-based solar power, with its potential for abundant, clean energy, could play a pivotal role in this energy revolution. By capturing solar energy directly in space and transmitting it to Earth, we can significantly reduce our reliance on fossil fuels. As we venture further into the 21st century, the need for sustainable energy solutions will only become more urgent. Climate change and depleting natural resources demand that we innovate and adapt at an unprecedented pace. Space-based solar power, once a dream of science fiction, is now within our grasp, a beacon of hope in our quest for a brighter, more sustainable future. This technology symbolizes our ability to turn visionary ideas into reality, paving the way for a world where clean, renewable energy is accessible to all. Section 9. A Cosmic Perspective. Our place in the solar system. As we contemplate the possibilities of space-based solar power, it is worth reflecting on our place in the cosmos. Our planet, Earth, is just one of many in our solar system, orbiting a star that provides the energy necessary for life as we know it. We are a species bound to a planet, dependent on the energy of a star. This star, our sun, is a massive nuclear reactor, constantly emitting energy that sustains life on Earth. Without it, our planet would be a cold, lifeless rock, floating in the vastness of space. This realization, far from limiting us, should empower us. It reminds us of our potential to reach beyond our terrestrial confines and tap into the boundless energy of the cosmos. The very fact that we can dream of harnessing solar power from space is a testament to our ingenuity and ambition. We have the capacity to understand the universe and to harness its forces for the betterment of humanity. Our scientific advancements have brought us to the brink of a new era, where space-based solar power could revolutionize how we generate and consume energy. Space-based solar power is a testament to this potential, a symbol of our ability to overcome challenges and to create a future where the stars themselves power our dreams. Imagine a world where clean, renewable energy is beamed down from space, providing an endless supply of power for generations to come. The journey towards a sustainable energy future will be long and demanding. It will require the combined efforts of scientists, engineers, policymakers, and visionaries from around the globe, but the rewards will be immense, offering a cleaner, more sustainable world for all. But with each step we take, with every innovation we pioneer, we move closer to a future where humanity thrives in harmony with our planet and the cosmos beyond. Our place in the solar system is not just a point in space, it is a position of potential, a vantage point from which we can shape a brighter, more sustainable future for all. Our civilization faces a critical challenge. This challenge is energy. We need energy to power our homes, our industries, our very lives. Looking outward, we see a universe brimming with energy. The sun, a giant ball of burning plasma, bathes our planet in more energy than we can currently utilize. Yet, we grapple with an energy crisis. This is because our current energy sources are unsustainable. Fossil fuels pollute our planet. They also contribute to climate change. We need to find a new way to power our world. We must look beyond our atmosphere to the endless potential of space. It's time to explore a revolutionary solution: space-based solar power. Our dependence on fossil fuels has brought us to a crossroads. The burning of coal, oil, and gas releases harmful greenhouse gases into the atmosphere. This traps heat and warms the planet, leading to climate change. Climate change poses a significant threat to our planet's delicate ecosystems and the future of humanity. Renewable energy sources like solar and wind power offer a cleaner alternative. However, they are limited by Earth's day-night cycle and weather patterns. Solar panels can only generate electricity during the day. Wind turbines rely on consistent wind speeds. These limitations pose challenges for reliable, continuous energy production. We need a solution that transcends these limitations. We need an energy source that is abundant, consistent, and accessible to all. Imagine a future where energy is abundant and clean. Picture this: giant satellites orbiting Earth, capturing the sun's energy and beaming it down to us. This is the promise of space-based solar power, or SBSP. SBSP involves harnessing the sun's energy in space, where it is constant and readily available. This energy is then converted into electricity and transmitted wirelessly to Earth. This technology has the potential to revolutionize our energy landscape. It could provide a sustainable solution to our growing energy demands. SBSP offers a way to break free from the constraints of Earth-based energy sources. SBSP systems consist of three main components. First, large mirrors in space focus sunlight onto solar panels. These panels convert the sunlight into electricity. Second, this electricity is then converted into microwaves or lasers. These are forms of energy that can travel through the atmosphere. Third, receiving stations on Earth capture this energy and convert it back into electricity for distribution. One of the key advantages of SBSP is its ability to collect solar energy continuously. SBSP systems are not subject to Earth's day-night cycle or weather patterns. They can generate power 24 hours a day, 7 days a week. This makes SBSP a potentially more reliable source of energy compared to Earth-based solar and wind power. Section 5. The advantages of SBSP: uninterrupted energy and a cleaner planet. The benefits of SBSP extend beyond its continuous energy generation. SBSP offers a cleaner alternative to fossil fuels. It produces no greenhouse gas emissions during operation. This makes it a crucial tool in the fight against climate change. SBSP also has a minimal impact on the environment compared to traditional energy sources. It doesn't require large amounts of land for solar panels or wind turbines. It does not produce harmful byproducts. Furthermore, SBSP has the potential to provide energy access to remote and underserved regions around the world. This could be a game changer for developing nations and communities lacking access to reliable electricity. Section 6. Overcoming the challenges. Technological hurdles and safety concerns. While the potential of space-based solar power is enormous, several challenges need to be addressed before it can become a reality. The concept promises a revolutionary way to harness the sun's energy, but the path to implementation is fraught with obstacles. One of the main challenges is the high cost of launching and assembling large structures in space. The logistics of transporting massive solar panels and other necessary equipment into orbit are complex and expensive. The development of reusable rockets and advancements in space manufacturing are crucial to making space-based solar power economically viable. Reusable rockets can significantly reduce the cost of multiple launches, while in-space manufacturing can help build and maintain these structures more efficiently. Another challenge is the efficient transmission of energy from space to Earth. This involves converting solar energy collected in space into a form that can be safely and effectively beamed down to the planet's surface. Scientists are exploring different methods, including microwaves and lasers, to ensure safe and efficient energy transfer. Each method has its own set of technical hurdles and safety concerns that need to be meticulously addressed. There are concerns about potential interference with other satellites and communication systems. The space around Earth is already crowded with satellites, and adding energy transmission systems could complicate matters further. Safety is a paramount concern. Ensuring the safety of astronauts, ground personnel, and the general public is critical to the success of space-based solar power initiatives. It is crucial to ensure that the energy beams used in space-based solar power are safe for humans, wildlife, and aircraft. The potential impact on the environment and aviation must be thoroughly evaluated and mitigated. Researchers are developing sophisticated targeting and control systems to mitigate any potential risks. These systems aim to precisely direct energy beams and prevent any accidental exposure to unintended targets, ensuring a safe and reliable energy supply from space. Section 7. Space-based solar power in action, from concept to reality, advancements and investments. Despite the numerous challenges, significant progress has been made in recent years in advancing space-based solar power technology. This innovative approach aims to harness the sun's energy directly from space, where solar panels can operate at maximum efficiency without the interference of Earth's atmosphere. Several countries, including the United States, China, and Japan, are investing heavily in space-based solar power research and development. These nations recognize the potential of this technology to provide a sustainable and virtually limitless source of energy, which could revolutionize the global energy landscape. For example, in 2023, a team of researchers at the California Institute of Technology successfully tested a prototype space-based solar power system that wirelessly transmitted energy over a distance of 1 mile. This milestone is a testament to the rapid advancements being made in this field. This breakthrough demonstrated the feasibility of wireless energy transfer, a key component of space-based solar power. The ability to transmit energy wirelessly from space to Earth could eliminate the need for traditional power grids and infrastructure, paving the way for a new era of energy distribution. Private companies are also entering the space-based solar power arena. These businesses see the potential for significant returns on investment as the technology matures and becomes more commercially viable. SpaceX, with its ambitious Starship program, aims to reduce the cost of space launch significantly. By lowering the financial barriers to space access, SpaceX is enabling more frequent and cost-effective missions, which is crucial for the deployment of space-based solar power systems. This could make space-based solar power more commercially viable in the future. As the technology continues to develop and costs decrease, we may soon see a world where space-based solar power plays a central role in meeting our energy needs, providing a clean and sustainable alternative to fossil fuels. Section 8. Space-based solar power versus other renewables, a comparative analysis. Compared to other renewable energy sources, space-based solar power has distinct advantages. Unlike wind and hydropower, which are location-dependent, space-based solar power can be deployed anywhere on Earth with a receiving station. While geothermal energy relies on specific geological conditions, space-based solar power is universally accessible. However, space-based solar power is still in its early stages of development. It faces significant technological and financial hurdles. Other renewable energy sources, such as solar, wind, and hydroelectric, are more mature and cost-effective in the short term. Section 9. The future of space-based solar power, a paradigm shift in global energy. In this chapter we delve into the transformative potential of harnessing solar energy from space, a concept that could revolutionize how we power our world. Space-based solar power holds immense promise for the future of energy. By capturing solar energy directly in space, we can bypass many of the limitations faced by terrestrial solar power systems. such as weather conditions and the day-night cycle. While challenges remain, such as the high costs of launching and maintaining satellites, the potential benefits of space-based solar power are too significant to ignore. Engineers and scientists are tirelessly working to overcome these hurdles, developing innovative solutions to make this vision a reality. As technology advances and costs decrease, space-based solar power could become a key player in the global energy landscape. The continuous improvements in space technology and the decreasing costs of solar power technology are paving the way for a new era of energy production. Imagine a future powered by clean, abundant energy from space. Cities illuminated by the power of the sun, captured and transmitted from space, providing a reliable and sustainable energy source. Imagine a world free from the constraints of fossil fuels and the environmental damage they cause. A world where renewable energy sources like space-based solar power have replaced fossil fuels, leading to a cleaner and healthier planet. This is the future that space-based solar power could help us create. A sustainable future where energy is abundant, clean, and accessible to all, reducing our carbon footprint and mitigating the impacts of climate change. Space-based solar power is not just about technology, it's about changing our perspective on energy. It's about rethinking how we generate and consume energy and embracing innovative solutions that can transform our world. It's about recognizing the vast potential that lies beyond our planet and harnessing it for the betterment of humanity. By looking beyond Earth, we can find new ways to meet our energy needs and ensure a sustainable future for generations to come. As we look to the stars, let us embrace the possibility and work together to make space-based solar power a reality. Through collaboration and innovation, we can turn this ambitious vision into a tangible solution for our energy challenges, creating a brighter future for all.